just gonna put this behind my ear. How are you? Oh, okay. What's the matter? Well, I mean, you look like... Is it raining outside? Is it raining outside? Yeah, you're all wet. Your hair. It's not... Oh, honey. It's okay. You can fix it later. Hey, what's the matter? Why are you so upset? You can tell me. You can tell me. You tell me everything. Oh. Okay. It's your classes? I know. Yes. First year of college is it's always kind of like a culture shock almost. Yeah. It definitely was for me. Hey, don't worry. Yeah. Mm-hmm. Well, you know I'm proud of you anyway. Following in your big sister's footsteps. Okay, so which class is giving you a hard time? Yeah. Calculus. Yeah. Mm-hmm. Hey, it's okay. It's okay. You know, sometimes we don't always understand stuff the first time we hear it, and you know, it takes a little bit of time to fully grasp certain concepts, you know. So this is your first semester of calculus, right? Yeah. Okay, so oh man, it's been a long time for me, but hey, if you tell me what you're going over and stuff, I think I might be able to help you. Listen, it's okay. You know, it's okay to not understand stuff the first time, and it's a good thing you have me because I can help you with stuff. I can help explain things if you need it. You know, you always have me. Okay? Yes. Hey, I love you. Don't let it stress you out, okay? I have been there. I have done that. I know classes can, you know, give kind of a heavy workload, but you'll get through it. It's not the end of the world. I know you're a perfectionist, and I know that it always has to be like the best for you, and that's not a bad thing at all. But I get how that can be really, really stressful sometimes. Yeah. And it's okay to ask for help. It's okay. And like I said, you always have me to ask for help. It's okay. We can go over stuff that you need to do right now. I'm just going over some mechanics stuff for a class. I just was confused about a little bit of stuff. See, I was confused too. See, and so I was going over it by myself to see if I could understand it on my own. Otherwise, I'm gonna ask for help. But no, I'm so glad you came to me. I'm really glad. And let's see if I can move some of this stuff over. Okay, so Do you have your book with you? Your calc book? No? Oh. I think you're using the what was it? Yeah. Larson Edwards. You're using the 10th edition, right? Okay. I actually do have that book, so we can just use mine. Don't worry. It's this one, right? This book? Mm-hmm. Okay, so let's see what we can do. What chapters are you going over? Yeah? Here. Let me scoot over. There. Okay, what chapters are you going over? Oh, so you're still in the very beginning. Okay. Chapters 1 and 2. Oh, okay. Let's see. Limits and their properties is chapter 1. And differentiation. Oh. Okay, so you're going over derivatives right now, right? Okay. So what do you not understand about that? Okay. We can go back to the beginning. It's fine. Don't worry. No. I'm not laughing at you. I'm just remembering when I was there at one point. Yeah. So we can do that. Let's see. Okay, so you just want to understand, like, how we get derivatives, I guess? The very basics of it, right? Okay. So you're a little familiar with, like, limits and stuff, right? Okay. Yeah, okay. I can definitely help you with that. Okay, so in section 1.1 of the book, it goes over something called the tangent line problem. Okay. So, in the tangent line problem, you're given a function f and a point P on its graph and are asked to find an equation of the tangent line to the graph at point P. Okay, so I'm going to draw this out for you. Okay. So we have our x and y axes, and we're given a function, okay, and it asks you to, it's asking, or somebody asks you to find the tangent line at a certain point on the function. So I'm just going to draw a point. We'll label it A, whatever. A, it's cool. And so the tangent line is here. Let me get my ruler. Okay, so the tangent line is basically the slope of the tangent. Okay, so tangent line is it crosses over, it crosses through this point, the point that they ask you to. And what they are really asking for is the slope of this line. And so our process is to find the slope of this line. Okay. Okay. So a way that we can do that is by using limits in the secant line. Okay. So a secant line is a line that crosses two different points it crosses two different points on the function. Okay? So now I put up another point, point B, and I have a line crossing through points A and B. Okay? You get that? Okay. So we can actually get the slope of the tangent line by using the secant line and its limits, or like the limit of it. Okay, so the secant line to find the slope of the secant line, and then this function is just f of x. We're just going to label the function f of x just because it's standard. And so the point A, we're just going to label on the x-axis as lowercase a, and then point B on the x-axis is we're just going to do a plus some change in a. Okay? Okay, so you see that? Yeah? Okay, so at point capital A, we have the function at A, and f of x, like our little f of x, is just like our function right here. We could just like even put that as y. So whatever x is, that is going to the function on the other side that's going to tell us y. So our function at point A is a and then f of a. And then at point B, we have a plus delta a as our x, and then f of a plus delta a as our y. Okay? So do you see what I did there? And so to find the slope of the secant line, we can do a slope is just rise over run. So that means rise over run is basically what is like on the vertical axis over run the horizontal axis. So rise would be the function at the certain points that we've selected, and then the run would be those points that we selected on the x-axis. Okay? Yeah. Okay. Yeah. So let's write that out right now. And we're going to label that m sub secant. And so that's just equal to the rise f of c, and it's the change in, so we subtract the smaller from the greater in this case. And actually, for the delta a's, we're going to change that to delta x because it's just some small change in x. It doesn't necessarily, I don't know, it doesn't necessarily have to be a change in a. So we will relabel that. Let's do it. Okay, so it's the rise over the run. And then we can simplify it because we have a plus a minus a. So that cancels out. Yeah? You understand that? Okay. Okay. And so to find the tangent line, this isn't in, I don't know if this is in this section. Anyway, to find the tangent line, what we can do is take the limit of the, of the secant line as delta x approaches zero. Okay, so what this means, the limit as delta x approaches 0, so remember that we have a plus delta x here, so that's just some change in the a on the graph. We don't know what the change is. As delta x approaches 0, what does this become right here? As delta x approaches 0? So when it becomes 0, yeah, that's right. It just goes to a. Yeah, that's exactly right. Yeah, it's okay. When it approaches a, right here, that's when you find the slope of the tangent line. Yeah, you're here. Hey. Okay, so do you understand what we're talking about so far? Yeah. Your hair keeps getting in your face. Sorry. Okay, so you understand that concept? Yeah. Yeah. Okay. Okay. So let's move on then. Okay. So what else do we have? I'm gonna go to chapter 2 now, so we can start talking about derivatives. Yeah? Okay, cool. Yeah, so we know how to find the tangent line. And once you know that, I'm going to go back to x's. Okay, so let's just make this a little bit more generalized, I guess. Yeah? Yeah. Okay. So we're gonna generalize this, and instead of labeling a particular point A or whatever, we're just going to label it x, just to be generic. Okay, so we're still finding the slope of the tangent line, and so it's the limit as delta x approaches 0 of f of x plus delta x minus f of x over x plus delta x minus x. And then that again cancels out and goes to delta x minus as delta x approaches 0. The limit as delta x approaches 0. The limit as delta x approaches 0 of f of x plus delta x minus f of x over, and then remember that x minus x cancels out. Yeah. Okay. Over just delta x. Okay, so you see. Can you see this? Right here? So this is what we end up with. And this is basically the definition of a derivative. Yeah. Okay. And we label that f prime of x. Because the prime is just to show that it's derivative of the given function f of x. And there's several different ways that people can write it. So if you see these, I can show you in a different form. So I am just going to write out the different ways that you'll probably see a derivative in an equation or whatever. So of course we have f prime of x, but we could also have ddf of f of x you can see it written like that, or even sometimes they'll just be short and write df over dx. That's how I usually write it. Yeah. Or you'll even see it like y prime or dy dx. I think that, yeah, so there's another way you might see it, dx of y, right there. Okay, so these are a bunch of the different ways that you might see it show up in life or whatever. Yeah. So don't get freaked out. Don't get freaked out. Yeah. Yeah. Okay, so you with me so far? You kind of get what we're talking about? And again, this is just, it's very general form. So we don't actually know like what x is, what delta x is, or what the function is. Yeah, I know, it's weird, right? Okay, so we know that, and what else do we need to know? Okay, so I can go over a couple different basic. I can go over a couple different basic differentiation rules, just to kind of get you started. Okay, so these are in your book. Mm-hmm. So it's pretty important that you read your textbook. Yeah. I know. I actually really, really hate reading, but I found it very, very helpful when I actually do the reading. Yeah. So read your book. I know. There's like no time for anything ever, but it's okay. You'll get through it. You'll pull through. You'll make it. You'll pull through. You'll make it. I believe in you. I believe in you. Don't worry. Okay. Okay, so we're gonna go over a couple different rules, and the first one I want to go over is the constant rule. Okay, basically this rule says that the derivative of a constant function is equal to 0. So, constant rule. The derivative of a constant is equal to 0. So the derivative of a constant is equal to 0, where c is just some constant. We don't know what it is. Okay, so we're gonna prove this. And so what we need to do first is set some standards, okay? Yeah, okay. So our first standard is we let our function be equal to c, where c is the constant. C is constant. Where c is constant. Okay, so now what we do is we take our definition of a derivative and put it in that definition, okay? So we use our little formula with the limits. Yeah, and we just put it right in there. Yeah, okay. So our f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Okay, so we can plug in our constant both for f of x and f of x plus delta x, because there is no actual, there is no x in our function, because the c, it's just a c. There's no x attached to the c or anything like that, right? Okay, so that means the x plus delta x doesn't make a difference. So what we do is we plug that in to our formula. C minus c is equal to delta x over delta x over delta x. The limit, so we have the limit as delta x approaches 0 of, on top we have c minus c over delta x. And I think you can see what I'm getting at, right? Okay. So parentheses first. Let's do what's inside. So we have our c minus c, which is 0, over delta x. And we do this first before we do the limit, okay? So that turns into the limit as delta x approaches 0 of, what's 0 over delta x? Yeah, it's 0, right? And so the limit as delta x approaches 0 is equal to, yeah, that's right, 0. Okay. You've got this. You're good. Hey, you're good. You've got this. Okay. So here's our constant rule and our proof. Yeah, great. Okay, so I think we should move on to the next one, okay? I think you can do it. I think you can do it. Okay, so let's move on. Okay, so this rule of differentiation is what we call the power rule, and we're going to, first of all, I'm going to tell you what it is. You probably already know, but I'm going to tell you what it is, and we're going to prove it as well, the same way we did with the constant rule. Yeah. Okay. Yeah. So let's go ahead and do that. Okay. Okay. So basically, with the power rule, you have a function f of x is equal to some x to the power of n. We don't know what x is and we don't know what n is, but that's the way it's supposed to be for like the generalized form. Yeah. Okay, so we have our f of x is equal to x to the power of n. Sorry if it doesn't look like great, but yeah, that's what it's supposed to be. Yeah. Okay. So the derivative of that, then, dx of x to the n is equal to n, whatever n is, times x to the power of n. So we have our derivative of x to the n, and it's just equal to n times x to 1 less than n. Yeah. Okay, so I'm gonna show you how that works right now. Hey. Don't freak out. It's okay. You're fine. Yeah, I'm gonna go through it with you. Hey, it's okay. Yeah, just take a deep breath. Yeah. So aside from this, are your other classes going well? Okay. Yeah, a lot of the physics courses all tend to run together, so it's no surprise that if you're lost on something, you might be a little bit confused about other courses as well. But you know, in the end, it all comes together quite beautifully, and yeah. So you'll see that eventually. Yeah. But for now, you know, there's no reason to be, you know, stressed out about this. And, you know, I can go over this stuff as many times as you need me to. Yeah. Well, you know that you're always welcome in my room, so if you need me, you know, just come in. Yeah. Okay. Yeah. It's okay. Okay. We ready to get back? You got this. I believe in you. Okay, so you understand, like, you know what I just wrote down, right? Okay, so I'm gonna show you. So a proof is basically just showing you how we get to that rule, and we get to that rule by, again, using the very definition of a derivative. And yeah, so let's do that again. So proof this pencil is, I don't know why I don't have mechanical pencils. I usually only use mechanical pencils, but oh well, it's okay. It's okay. Use the yellow one because it's like bright and happy, right? Yeah. Okay. So the derivative of x to the n, and we're going to stick this right into our definition. So it's equal to the limit as x approaches 0 of x plus delta x to the n, because that's what our function is, it's raised to the n, minus just regular x to the n over delta x. Okay? Okay, and so for this little guy right here, we gotta kind of FOIL that out. FOIL is like it's like when you have something in parentheses. Okay, so FOIL is like if you have something in parentheses and it's squared, you start with the front, you multiply those two together, and you go to the outer two, so the first and the last one, and then I stands for inner, so you multiply the inner two, and then FOIL, FOIL, front, outer, inner, last. Last. So then after that you multiply the last two together, and then you just add them all up. Yeah. So we're going to kind of do that with x plus delta x to the n, but we don't know what n is, so we got to kind of do this a really generalized way. So let's do this a very generalized way. Okay, so x plus delta x to the n is equal to, so it's going to be some x to the n plus some n to the x to the n minus 1 times delta x plus delta x squared times n times an n minus 1, we don't know what it is, times x to the n minus 2 over 2, and then you keep going on and on, blah blah blah. We don't have to write everything out, otherwise we'll be here forever. And then it ends with the delta x to the n, whatever that is. Okay, so this right here is kind of what we end up with. Yeah, okay. So you guys, we just FOILed it out to the whatever, to the end, whatever. Okay, so we're going to put that right back in for x plus delta x to the n. So this is equal to the limit as delta x approaches 0 of x to the n plus n times x to the n minus 1 times delta x plus 1 half n times n minus 1 times x to the n minus 2 times delta x squared plus blah 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 plus delta x to the n, and then minus x to the n because we're back to our original equation. Yeah? Okay. And this is all over delta x, because this is just plugging it right back in to what we had originally. Yeah? Okay, you with me? You with me? Okay, yeah. So we have a positive x to the n and a negative x to the n on the top. So we can just cancel those out because they add up to equal. Yep, they equal 0. Okay, so let's rewrite what we have. Okay, so we have the limit as delta x approaches 0 of, on top we have n to the x to the n, or n times x to the n minus 1 times delta x plus 1/2 n times n minus 1 times x to the n times delta x to the n over delta x. Okay, do you get it so far? Okay. So then we're just going to simplify that a little bit more. And so what we have, since we have a delta x in like everything, we have a delta x in the bottom, we can just kind of cancel everything out. Cancel all the delta x's out, or start canceling them out. Okay, so for our first, so it's like up here. So the only one that ends up without a delta x is the very first term. So everything else in it still has at least one delta x in it. Okay, you got that? Right? Okay. So then, now we can actually do our limit, okay? So as the limit of delta x approaches 0, there's only one term that doesn't have the delta x in it, and that's our first term. But all the other terms, as delta x approaches 0, what do you think they're going to turn to? They're going to end up as? Okay, well, what is 0 times anything? Yeah, okay. It's a 0. So as delta x approaches 0, those terms are going to end up as 0. Okay? You get that? Okay, yeah. So let's kind of rewrite that out. So we have our very first term, n times x to the n minus 1 plus goes to 0, plus next one goes to 0, plus so on and so forth, plus 0. You see that? Okay, and so what is anything plus 0? It's just the anything, right? Okay, so what's our anything here? What's our anything here? I am gonna give you a hint. Yeah, it's just this. Okay, so we can write that. Let's rewrite it now as our dx of x to the n, and it's equal to n times x to the n minus 1, because all our zeros cancel out. Yeah. So then look at what we end up with. You see that? And what was our original equation? Right here, right? Now, is that the same thing as this? The same thing as that? The same thing. The same thing as that. Yeah. Right. So we just proved it. Yeah. Yeah. You've got this. Do you understand how we got that? Okay, cool. Yeah. See, you're gonna do fine. You're going to be so fine. Yeah. So I think that that's probably good enough for now. Unless, did you have any other questions right now? No questions? Okay, cool. But yeah, so if you do end up having any more questions, go ahead and just come to me. So anytime you want. Yeah. Hey, you're gonna be fine. Don't worry about it. You're cool. You're good. You've got this. You've really got this. Yeah. So yeah, once you start understanding like the basic stuff, then like it's like everything just clicks. So yeah, so oh, you've got something to do now. Okay. Well, I'm really glad that you came and stopped by, and yeah, anytime that you want to work on stuff, or you just want to talk to me, I'm always here for you. I'm always here for you. Yeah. Hey, I love you. Yeah, I hope. Hey, you've got this. You're gonna be great. Okay, so I guess I'll see you later. Yeah. Come back anytime.